Let's look at trig related rates homework, page 156, 157, 43, 45, and 47. So 43, a balloon rises at a rate of 3 meters per second from a point on the ground 30 meters from an observer. Find the rate of change of the angle of elevation of the balloon from the observer when the balloon is 30 meters above ground. So if we draw a triangle, the observer is standing at a point, and then 30 feet away the balloon is rising, and the y represents the height of the balloon at a given moment in time, and then this theta is the angle that we're trying to, well, d theta dt is what we're trying to look for. So balloon is rising at a rate of 3 meters per second. This is talking about the rate of change, right? Rises, this is changing value, and we're going to assign that to be dy dt. Notice that your y is changing, but the y is going to be increasing over time, so we know that dy dt will have to be a positive value. Okay, d theta dt we're looking for, dy dt positive, 3 meters per second. Then and it says when the balloon is 30 meters above ground. So at this moment in time, the y value is 30 meters. Okay, but we don't want to plug 30 in for the y when we create our trig function, because we lose the ability then to find the derivative. So our first starting equation is tangent theta is equal to y over 30, right? The trig function that will relate both are given pieces of information there, opposite over adjacent. So rewrite this, tangent theta is equal to 1 over 30 times y. Okay, so now we're ready to find the derivative. The derivative rule for tangent theta is secant squared theta. We're involving theta's derivative, so we got to attach d theta dt. 1 over 30 times y becomes 1 over 30 times dy dt. Okay. We're trying to solve for d theta dt, so we divide the secant squared to the other side of the equation. So 1 over 30 times secant squared theta times dy dt. I'm going to move the secant squared up to the top, thinking work this problem out in terms of cosine squared theta. Okay, dy dt we have, right, 3 meters per second, but we don't know what theta is, but we can find out what cosine of theta is, right, based off the the information that's given to us for all the sides. We know the x is 30, we know the y is 30. We can think of this as a 45, 45, 90 triangle, which means the value is 30 root 2, or we can just go through a term and find out that the hypotenuse is 30 root 2. Cosine of theta is adjacent over hypotenuse, so adjacent is 30, hypotenuse is 30 over 30 times root 2. Reduce that to be 1 over root 2. So plug this back into our equations, or formula so far. Cosine squared theta can be replaced with 1 over square root of 2 squared, which becomes 1/2. So 1/2 times 1 over 30 times 3 reduced to be 1 over 20, and then that's going to be our rate of change for theta. So 1 over 20 radians per second. Right, 45. Airplane flies at an altitude of 5 miles towards a point directly over an observer. The speed of the plane is 600 miles per hour. Find the rate at which the angle of elevation theta is changing. So here we're looking for d theta dt for when the angle is 30 degrees, 60 degrees, and 75 degrees. So based off of this, I'm going to draw a triangle. The observer is here. The plane is moving towards the observer. So we can think of this as the same as this x. Okay, dx dt, this x is going to be decreasing over time. So we know it's negative 100 miles per hour. Okay. The y is 5. We want to create a trig function that will relate these three pieces of information together. So we use tangent again. Theta is equal to opposite over adjacent, 5 over x. I can rewrite this as 5x to the negative 1 to prepare it for power rule. So tangent becomes secant squared theta, d theta dt. Negative 5x to the negative 2 times dx dt, we go through power rule. Move the secant squared over to the other side. And so we're left with d theta dt is equal to negative 5 over x squared times cosine squared theta. And we move the secant squared to the top times dx dt. So we're going to keep coming back to this as we solve for a, b, and c. Okay, so for a, theta is 30 degrees, x, if theta is 30, then we know that x is going to be equal to 5 root 3. So we can use information from a triangle, or we can just plug it into the formula and just figure out what cosine of pi over 6 is. So d theta dt is negative 5 over x. My x value is 5 root 3. Since theta is 30, my y is 5. So using this, the ratio of the 30, 60, 90 triangle, I know that my x is 5 root 3, my h is going to be 10. So 5 root 3 squared times cosine of pi over 6. Pi over 6, same thing, is 30 degrees. Pi over 6 squared times dx dt. Cosine of pi over 6 is root 3 over 2. We got to still remember to square that. Dx dt is negative 600. And clean all this up. We get negative 5 times 3 times negative 600. Divide by 25 times 3 times 4. Cancel out the remaining, the appropriate values, and we get 30 radians per hour. Okay, part B, when theta is 60, then we have to make the adjustment with the sides. So if that, the y value is 5 for 60 degrees, we know that to get to this side, it would be 5 divided by root 3, and the hypotenuse is therefore 10 over root 3. So d theta dt is negative 5 over x squared. My x is now 5 over root 3 squared times cosine of pi over 3 squared. Pi over 3 is the radian for 60 degrees. Cosine of pi over 3 is 1/2. 1/2 squared is 1/4. And 5 over root 3 squared is 25 over 3. And we put all this in the same fraction, cancel out, we get 90 radians per hour. Okay, part C, we're going to need a calculator because 75 degrees is not something that we can figure out using special right triangles. So we have to figure out what the x value is. So to find the x value, I'm going to label this as x, and we can use tangent, right? Tangent of 75 is equal to 5 over x. Plug this in the calculator, solve for x. 5 over tangent of 75 is 1.3397. And then leave this in degree mode. So cosine of 75 squared times negative 600. All this in your calculator, it will give you 111.96 radians per hour.